Hi, this is Julia Bell, and welcome to Chapter 3 of ccna1. This is Part 2B, Standards Organization. Let's talk about the ISO. This model is our basis for discussing networking. The basic layers, I'm going to start from the bottom and go up. These are considered media layers, these bottom three. You have physical, cable, signal. I think of binary at this level. As I move up, data link, physical addressing, whether it be the MAC address, which is burned onto the LAN card, or the logical link. Here you have your network layer. Path determination router here, a logical address like an IP address that your administrator has given. Transport layer takes care of end-to-end connectivity and reliability. Session, interhost communication, presentation, data representation and encryption. Application is a network process to applications. The fourth layer, for instance, here, 1, 2, 3, and 4. 4 is transport. To describe the ordered and reliable delivery of data between your source and your destination. The source is the sender. Destination is where you're going. Here's the OSI kind of in a nutshell. You really need to know everything on this slide. This is very powerful, very important slide. The benefits of using a layered model like this, we have 7 layers, but the benefits of using a layered model in networking communication is it fosters competition among devices and software vendors by enforcing the compatibility of their products and by enforcing those standards. Again, 7 all the way down to 1. The 7 is the layer that's closest to the end user. For instance, we give an example of a web browser. An end user might be at their computer, type in an address in a browser. Magic happens. Well, it's a little more than magic. It goes through these layers before it even goes out of the building to where it even goes to the web server and brings back the information. It starts out with a web browser, goes down to the presentation layer, which is a common data format, goes to the session, then it goes to the transport layer for flow control, reliability, and sequencing. At this point, they're called segments when it breaks it apart. Network layer, layer 3, is where you do routing, path determination, which way is the best way to go, and the logical addressing or our IP addressing. The data link layer frames a media access controller, which is your MAC address that's burned into the NIC card. Physical of hardware like cabling, your NIC card. You think of, if it's fiber, you think of the on and off light waves. If it's wireless, you think of a radio wave at this point. Equipment here might be a transceiver, a repeater, or a hub. Notice where switch is on layer 2. You need to become familiar with everything on this slide. Other standards organizations. Here is your Electronic Industry Alliance, the EIA, the Telco Industry Association, the TIA. The ICANN is the Internet Corporation for Assigning Names and Numbers. IANA, which is the Internet Assigning Numbers Authority. Benefits of using this layered model, again, would be fostering competition among devices and software vendors by enforcing the compatibility of the product. Here's an example of the OSI and the TCP model side by side. These are two different models. They have some things in common and some things very different. The OSI model has 7 layers. 1, 2, 3, 4, 5, 6, 7. The TCP model has 4 layers. 1, 2, 3, 4. They combine these 3 layers from OSI, application, presentation, session, into one on the TCP, and they call it application. It has to do with HTTP, which is web browser, domain name services, DHCP, which hands out addresses automatically to equipment, file transfer. The transport layer is one layer that they both have in common. So if you see a question that asks, what do the two have in common? What layer is the same? It would be the transport layer. It's got the same exact name. You would find TCP at this level, or UDP. I call it unreliable data protocol, because no error checking is done with UDP. Internet layer, it's still one level, but it corresponds to network layer. Your IP version 4 and 6 addresses reside here. Your network access is on the TCP model. It's a combination of data link and physical from your OSI model. And what resides here is the frame relay, the point-to-point, and your Ethernet. Make sure you're able to match those OSI layers to the TCP layers. I find that if you have a good solid understanding in Chapter 3, when we progress on in later chapters, you get it. Being able to match these up and to know how they are now will pay great dividends later. I promise you it's worth the practice. TCP reference model looks much simpler to the naked eye. If I've got a PC on this side who wants to send a piece of email, it would start at application layer, proceed through transport. At the internet layer, it's going to get an IP address. At the network access layer, it prepares itself to go out on the Ethernet cable. When it reaches the other side, crosses the Ethernet cable, goes back, strips off the IP address, checks it, does it match this PC? The transport protocol, make sure it's ordered, ready to go. All the segments are there and they are in the correct sequence. And the application layer presents it as an email to the end user. Comparing OSI and TCP models, again, learn these layers, learn these models, learn how they are alike and how they're different. It will pay big dividends later on. You'll notice transport is named the same. So TCP IP transport and OSI layer transport provide similar services and functions. You need to know that. And that is the end of number 3, part 2.